Now, let's start to look for these local extreme values. Let's look for these local minimums and local maximums. So in general, we would call these extreme values, or if you want to get Latin about it, we might call them extrema. So how do we find these things? Well, in that last problem that showed up, there were already some minimum and maximums, and they mostly lined up with exactly those critical points that we were testing. So this is going to be one of our tests to find a local extreme value. Does the sign of the derivative of f, so sign, does it change from positive to negative? Or does it change from negative to positive? In those two cases, that means the function used to be increasing, and now it decreases. Oh, a maximum. Or the function was decreasing, and then it changes course and increases instead. A minimum. So this is the test. Number one, find all of your critical points. Number two, test your derivative at coordinates to the left of that critical point and to the right of that critical point. So you only need one of each there. And you're going to keep track of whether the derivative is negative or positive, right? This is what it means to take the sign of a function, or the sign of a number. We only care if it's a number below zero or above zero. So depending on what we get, this test will tell us whether we have a local minimum, local maximum, or just a false positive, nothing special. So again, if we go from positive to negative at a critical, if our slope goes from positive to negative at a critical point of the original function has a maximum at that critical point. If the derivative goes from negative to positive at that critical point, then the original function has a local minimum. And finally, if it's positive on both sides of the critical, if the derivative is positive on both sides of the critical point, or if it is negative on both sides of the critical point, the function f does not have an extreme value at that coordinate. So in terms of pictures, what's going on, if we think about these two different parabolas, here's a very classic example of a maximum. Coordinate C here is the x coordinate for this maximum. It's also the x coordinate for this horizontal tangent line, which is telling me the derivative of the function at the maximum is 0. So a critical point. Now, my derivative is going to be positive to the left of this maximum value. The derivative is going to be negative to the right of this maximum value. So negative, so if you have a derivative which goes negative to 0 to positive, your original function has a maximum. If your derivative goes reverse that. If your derivative goes positive to 0 to negative, you have a maximum. If your derivative goes negative to 0 to positive, you have a minimum. Now, here is an example of something that's not a maximum or a minimum. Let's look at these cubics. I've gone, derivative is negative, derivative is 0, derivative is negative again. That's not a maximum. It's not a minimum. It's something else which we'll be giving a name, but for right now, it's not a maximum and it's not a minimum. So not what we are looking for right now.